In the last episode, we figured out how to make chapter files that controlled the progression of our story through classes that could be saved and edited in the inspector window. Well, though that may work, not everyone was looking for that, and the feedback I got inspired me to construct a new and better method. So today we're actually trashing last week's work. Yeah, sorry about that, but trust me, you're gonna like this better. Even I like it tremendously more than the latter approach. So what is this new method? Well, it's called scripting. And no, that's not the same as coding. We're basically going to take a text editor of any kind and write out the script of our visual novel, chapter by chapter. Doing this not only looks better, but it offers a ton of features that'll be useful as we dive deeper into the writing process, such as reorganization, simplicity, and fine features to name a few. So I will actually be deleting the previous episode on chapter files when this video is uploaded because it no longer applies. But I'm not going to waste time showing how to recreate the FileHandler all over again, so that script will be posted in the description. Please take a moment to download that now because we will actually be using that very shortly. I try to make it a point to plan everything out beforehand to the best of my ability so we don't have to go back and start over on something. This is a tutorial series after all, not a whoops my bad series, so this will be the only time I allow that to happen. Let's start by removing the saved chapter files testing script from our tester object, since we won't be making chapter files that way anymore. Then navigate to your core scripts and delete the chapter manager. Then delete the saved chapter files testing script as well. And make sure to remove the chapter manager from your game object in the scene. Now let's begin. If you're new here, this is the part where you can begin to follow along. Just wait for everything to recompile and clear out these errors. Though chapter files will be in TXT format, at least until we build the game, that is. That means you can edit them in any text editor of your choosing. So as long as the application writes in TXT format, which you'd be hard-pressed to find anyone that doesn't, then you can use it. But do yourself a favor and find one that offers more capabilities than just typing. You'll probably want one with a spell check for one thing, and the find feature for locating specific text is pretty good too. First off, we need to take a moment and figure out how we want our visual novel script to look and function. You need to figure this out and write down a plan before you get started. This includes the flow of the file, any special commands, and how dialogue is going to be interpreted. Consider using a command database that you can reference, reminding you what commands you've set up to be supported and how they should be called. Here, my command file tells me everything I can put into my chapter file and what format Unity will expect it to be in. The text editor I'll be using is called Atom, and you can download it from the link in the description. One great thing about Atom is I can set two documents side by side like this, so I can write my chapter in one window and see my commands in the other. I also appreciate the autofill feature that comes up as you're typing, so with my command document open, commands are automatically suggested based on what I'm typing. And in Start, I'm going to load the chapter I was showing you guys earlier, which isn't really a chapter, it's just a kind of a test of different features. But we'll call it a chapter for now. So that line will populate our data with the lines of chapter 0. And now in Update, what I want to do for now is just proceed through the data every time I hit the right arrow key. In order for me to do that, we need to know how to handle a line. So let's make a function for that down below. Now I can handle the line in our data at our current progress. And increment progress by 1 afterwards, that way we move to the next event on the next click. So look at your file and examine how it's most natural for you to write dialogue for a character. When I do it, I write the character name, space, quotation, dialogue, end quotation. There may be a plus in there if I want additive, but the format is the same. Details about the dialogue preceding the dialogue itself, and then any events come after the dialogue. So when I want to do something special to happen, like an action, it always comes after any present dialogue. So my format for any line is literally dialogue details, dialogue, and then actions. So if all 3 are present in a line, then I should wind up with 3 separate chunks of data to work with. Now the key to separating these data types is the quotation marks, encapsulating my dialogue. Because of this, I know I need to split my line by the presence of quotation marks. Doing that will give me 3 separate strings, my dialogue details, dialogue, and actions. So let's do that. We've got our current line, now split it by the quotation mark character, and store it into an array of strings. If dialogue is in the line, it'll result in 3 elements in our array. But if there's no dialogue, meaning the event consists of only actions, then we'll only have 1 element in the array. So we should handle the line according to its length then. Set the condition for if we have dialogue, and also if we don't. One thing though, when we load a new chapter file, be sure to reset the progress to 0. Now make a function for handling dialogue. Also, define a string to cache the most recent speaker. We'll need that when we don't define a speaker for our dialogue. And reset the cache when a new chapter is loaded. So remembering we've got our details preceding our dialogue, we should pass both of those elements into the action. Okay, now by default, our speaker should be the last known speaker, and additive should be true if our details contain the plus symbol, or whatever you decided was equivalent to that. By no means do you have to follow me exactly as I'm doing this, just feel free to experiment. Now if it's additive, then we need to remove the plus symbol from the speaker name region. I always place it adjacent to the first quotation mark, so I just need to remove the last character of the details. Like so. Next, if we define a speaker, then we need to update the speaker. So we find this if the length after removing my plus symbol is not 0. Another thing to be aware of is my space between my character and their dialogue. If I'm not careful, that space will be included in the character name, and I'll never actually get any characters to show up. I'll just run a quick check to see if the ending character in my character name is a space, and if it is, then I'll remove it. I'm doing it like this because some characters may have spaces in their names, and I don't want to remove all of them, just the one between them and their dialogue. Now I can set the speaker to whatever it really is and update the cache to match. Next comes the actual dialogue, but we should only try to show a character if they are not the narrator. So check the speaker against the narrator identifier and set a conditional if-else field. If this character is not the narrator, then we should get the matching character from the character manager and make them speak. Remember, by default, the character manager will create a character not in the scene, so be aware that you can set conditions for those values as well as have them enabled on start or not, although we will have commands specifically for that as well. On the other hand, if this is the narrator, then we only want to show the dialogue, so we'll go straight to the dialogue system for that. But before that, I'm combining the say and sayAdd method in my dialogue system to incorporate the additive boolean. And since I'm doing that, I will also have to update the character's say method to only include the dialogue say method. Now with that taken care of, I'm calling the say function from my dialogue system. So call handle dialogue in our handle line, pass in the details, and then the dialogue, which are the first two elements in the array of 3 objects. In order to take care of the third or only element, we need a similar function to handle the events instead of dialogue. Give it a string parameter for the events on the line. So after we call dialogue, call the actions too. If dialogue is on the line, then our actions will be indexed too. Otherwise, it's the only element and it'll be at index 0. I'm only going to print the actions right now. I'm not going to do anything with them yet, since we're just focusing on dialogue right now. Now back in Unity, let's go ahead and add the novel controller to our scene. I'm going to attach it to my core game object. And that alone should allow us to read the dialogue from this chapter and show it on screen. Okay, and as I press the right arrow, the console shows some attempted actions, and there's the dialogue showing up. And since Raylene is the speaker, she's the one who popped up on the screen. So this controller is now reading events from our chapter file and handling the dialogue accordingly. Now we need our actions to take place. So let's do that back in our controller. All of our actions are passed in as a single string, so the first thing we need to do is isolate each action by splitting the string. I chose to split actions by a space character. Now consequently, I can't have any spaces inside of my actions, so any variable names called need underscores or no spaces at all. And now that I think about it, if a character name has spaces in it, that wouldn't work for me, so actually I may come back and change the delimiter to a double space or a semicolon or something. I'll do that at a later time. For now, make a function to handle a single action and loop through all of our actions, throwing them into that new function we just created. Now comes the moment where we have to define what action does what. So you see how I labeled my supported actions here? It's just like we would call a method from script. We have the action name followed by some required parameters in parentheses. I'll start simple and add support for set background. Since parameters are inside my parentheses, I need to split the action by both parentheses to isolate the action title from the parameters themselves. Store the result into a string array, where the first element is our title and the second is all of our parameters. And now we need to check this against some supported methods and call them depending on the action which is in data 0. In this case, I'm saying if the action title is set background, then I'll do something specific for that. In order to do that, I need a command to call if I have an action of set background. I'm calling it setLayerImage because I can use it for any layer, not just the background. It'll need the parameters of the action, as well as a layer to work with. So we call that up here, and give it data1, and the layer as our background layer. Then return. Okay, great, but I've got 3 layers, so I'm going to duplicate it to match my cinematic and foreground layers as well. Okay, so what do we do in this function? Well, I've got one required parameter, which is the name of the image I want. Then I have an optional parameter, which is actually the speed of the transition. So I need to get a texture by the name supplied, and then use the speed parameter if it's supplied, but using a default if it's not. And maybe I also want to set transition smoothing, so I'll go ahead and add that as an option as well. So now that we know what we need to do for this one, let's just go ahead and get it. In my case, I need a texture, and to get that texture, I need the name of the texture. Since I've got optional parameters, it's possible that my texture name can either be the only piece of data, or one of several. So to simplify this, if my data contains a comma, then my texture name is the first item. If it doesn't, then it's the only item. Once I've got the texture name, it's time to get it from our resources folder. So load the texture into a variable from the resources folder, following the path to your still and animated backdrops. I'll move both images and movies into the same directory, so I don't need a parent folder in the name of the texture. Now to find the default values for our speed and smoothing. Next, we need to handle any present optional parameters. We determine their presence through the comma character. If it's true and it contains a comma, then split the parameters and handle both the speed and smoothing values separately. The order of parameters isn't constant for me, so this is just so I don't have to worry about what order I put certain things in. However, because of that, I need to check each parameter to verify its type. You can make this work by making use of output variables and the try parse commands. For instance, if float tries to parse and it's successful, then I know this is the speed variable, and it'll output the speed value into my float container. Then I can set the actual speed target as the output. Likewise, if bool.parse is true, then the smoothing is cached, and I can update it from there. If one of these happens, then I want to continue to the next parameter. So once we've got all that figured out, we can transition to the target texture on our target layer. I better make this into a string array here where I get my actions, otherwise that's definitely not going to work. Now, since I set myself to look for images in the images folder, regardless of whether they're still or animated, I'm going to move my pictures and movies into the same directory. So our first command should be to set the background to an image called forest. It should not use smoothing, and the speed should be 1. So let's see that work. Press right arrow, and there we go. It read the command, interpreted what should be done with it, and we have our forest background up in visual. And of course it moves on, taking care of the dialogue and such. But the next command told us to play music. So now let's add a function to play music, and one to play sound effects. So the action itself is called play music, and it takes a song name. Let's do a sound effect first. Just like with the previous command, it needs to be checked, and we need an actual command to call. Let's also make one for music right now. And instead of using all these nested if statements, you'd be better off using a switch function. It's one of those do as I say, not as I do things. So just like with the image, we need to load the audio clip from resources, and then use the audio manager to initiate the sound effect. Use resources.load and go into your sound effect library, pulling the sound effect you want, add a directory into the sound name if you still want to organize them like that. And use Audio Manager's play sound effect method that we made a few episodes back to get that up and running. As a safety precaution, I'm only allowing this if the clip is not null, meaning if a clip is actually found based off of what I gave to the command. Otherwise, I'll log an error to the console and I can check it out later. Now, it's basically the same for music. Just copy and paste this function into play music. Now just change the sound library to the music library. And make sure that play sound is changed to play song. If all is well, we should have music playing on our first event, and it is. Music is playing by the command of our chapter file. Okay, so that's good. Now let's try a sound effect. I'll name this whoosh 1. Add the play sound command to my second line. And we get a nice whoosh sound effect playing. Okay, but how about setting the background to null? I should be able to easily say null to clear the image of a layer. So there's only one line I need to change here, and that's where I retrieve the texture. If the name is null, then get a null instance. Otherwise, get the texture from resources. And it's that simple. And that allows us to clear out any layer. So change the speed and smoothing a little, and suddenly we've got a differently paced transition. This is what I love about Unity. If you want to make something, there's almost nothing stopping you, really. So come up with your own clever commands and add functionality to them like we did with these 3. But that's all we've done, just 3 different types of commands. We've still got things like character movement, expression changes to do, but I'm pretty sure at this point I don't need to show anyone how to do that. Know what parameters you need, and make sure you use the action names verbatim in your chapter file and code. Now, regardless of my confidence in you guys, I'm still going to record myself creating these methods. I may not say anything for a while, but you can still follow along if you need to. So here we go, and let's go ahead and get started with character movement. Okay, so now we've come to an issue. I'm trying to load expressions by name through these commands, but currently I can only load entire sprite sheets or expressions by index through our character class. So I want to come into the character class and add a new getSprite variation that'll get a sprite from its sheet based on an expression name or a string. So change the parameter to a string, and then iterate through each retrieved sprite until we find a matching one. Return the first sprite if no match is found. Now allow us to set and transition expressions using strings instead of direct sprites or indexes. Now go into Unity and open the sprite sheet for your character. Go into the sprite editor and name all of your different expressions by clicking on them and changing the name field. Now we've got all our expressions labeled with names, and that's a good thing, because now we can make use of the name feature inside of our script here. Now let's use the transition body and expression functions to change the expressions on this character. Retrieve the sprite using our new getSprite function with the expression name. So there we have it. We now have a way of writing out our visual novel, and these are just a few of the commands that will be present in the visual novel. Add whatever you want to it, and by now you should see that it's actually pretty easy to do just that. The next episode is our showcase point. I'm going to recreate a scene from a real visual novel, and using just what we've made so far, I'll have it run inside of Unity through a script just like this. There's still more to be done, including saving, loading, encryption, input and choice screens, main menus, and things of that nature, but in reality, we're closing in on the end of the series. So, I hope you guys enjoyed the video, and I will see you in the next episode.